This makes it even simpler, you could say. But if we, instead of having two different hospitals with different nurses, so we investigated nurses, or we observed nurses at hospital A, and then observed some other nurses at hospital B. Then we had two samples, and we need to do a two-sample t-test. However, if another way of setting up the experiment would be a paired setup. And that would simply mean that we would take the same 10 persons, and then we would give them first. This is an example of medicine that we used last time, but last time we only tested for this where we had a single sample, but actually this stems from two samples, which was done in the following way. The same person first had sleeping medicine A, and then we saw how long do you sleep, and then they waited for some time, and then they had medicine B, sleeping medicine B, and then we observed how long time they slept. But we did that for the same person. And if we do that, and if we make sure that the medicine medicine A has disappeared before they do take medicine B, then we can simply, instead of doing a two-sample t-set, we can simply subtract the values, and then we just have a single sample, and we can do a hypothesis for that. So that's what we call the paired setup, because the samples are paired, and the point here is that if you take different nurses, all other differences, for example, their height and their weight and stuff like that, would also be adding noise and variation. So we would actually need more observations in order to conclude the same thing, or in order to discover the same effect. However, if we can do the paired setup, then we actually remove all this variation from height and weight and different, because we simply, for each person, we get the difference, and then we only use the difference in the test. And once we have this, it's just a one single t-test that we need to do to conclude whether these values are, the mean of these are different from 0. So that's a paired setup. It means just that the same person or entity is tested with different, for example, different medicine, or it could be the same 10 cars that rode in one condition and then in another condition. But the same 10 cars. If we had 20 cars and we made 10 of them drive in one condition and 10 of them drive in another condition and then use those, then that would not be paired. It's paired if we use the same one but observe the effect of two different things. And then we can just take the difference and do a one sample t-test. And the point is that if we ran that through R, we would get the same. So if I took these here, if I took these, the differences, these are the values that we saw before, I think. But if I then took the difference, then I could do a call t-test, and now it would be test is the mean of this one diff, is it different from 0? I would get this t-test, and I would get this p-value and so forth. If I could also call t-test with x2 and x1 given directly as argument, and then give the argument paired equal true, then I would simply just get the same results. Perfect. That is the that's simply the paired. And well, here you can see how it's yeah, the same thing as I've just said. Yeah, there's a little bit of, usually you would reverse the order whether they took A before B and something like that in a randomized way, so you would make sure you did not get, you get as little effect of things like that. But that's simply called paired, the paired t-test, the paired setup. Okay,